Hello friends, welcome to Mechanical Engineering online classes. Today's lecture will be delivered by Miss Shravani Sriramoju.
Group replacement is a replacement policy that is applied for items that fail suddenly. In this policy, a decision is taken to replace all the items in a system, whether they have really failed or not. That means if we take an example of an industry or institute or company or a plant, there may be a number of tube lights that can be bought in lot for a lesser cost. So we can find an optimal group replacement period to replace all the tube lights at the same time, whether every tube light is failed or not. Or another example is, for example, if an electrical plant, there might be number of resistors. The number of resistors may be in thousands. So we can decide an optimal group replacement period when to replace all the resistors such that the plant function is not interrupted and that the advantage of bulk orders and procurement can be taken. But since there is no guarantee that every bulb or every resistor or for that matter any item will fail with the group, means all the items will not fail at once, right? So it is possible that a tube light which is fit say 2 years ago will fail today. Another tube light which has been installed in the same time 2 years ago might have already failed some 2 days ago, or maybe it may fail some 4 weeks after now. So there is no guarantee that all the items will fail on the same day because they are installed on the same day. So even if one item is failed, so it is possible that the system may get interrupted, the functionality, its effectiveness will get affected. So it may be noted that any item which fails before the optimum group replacement period may be replaced individually. So now for example in our building there are 1000 tube lights. So according to our group replacement policy, if all the 1000 bulbs must be replaced say day after tomorrow, but one bulb failed today, so that bulb will be replaced today itself. Now again all the 1000 are there, the old 999 are there, and today's new one is also there. But because the group replacement policy says that day after tomorrow we have to replace all the 1000 bulbs, even this new one along with the old 999, all the 1000 bulbs will be replaced. So if an item is failing before the replacement period, then that will be replaced individually. Otherwise it will come into the group replacement period. All the items will be replaced as a group. Now let us understand the concept of group replacement policy with the help of an example. Let us see an example. This question says, the following failure rates are for a bulb in an automobile facility. The number of bulbs in the automobile facility is 1000 at the beginning, and the cumulative probability of failure is given for 8 weeks, total number of 8 weeks. Cumulative probability means first week the probability failure is given as 0.03. The second 3 it might be 0.12. So 0.03 plus 0.12 became 0.15. So similarly all the cumulative probabilities are given, and by the end of 8th week the probability of failure is 1. Cumulative probability of failure is 1. Means all 1000 bulbs have failed by the end of this 8th week. So that is what the question says. Now the cost of replacing an individually failed bulb is 1.3 rupees. If all the bulbs are replaced in a group, the cost per bulb is 0.32 rupees. As a group means as a lot, if we are changing all 1000 bulbs at once, then the cost per bulb is reduced. It is 32 pice per bulb. So if a decision is made to replace all bulbs at a time, means as a group at fixed intervals, and replace the individual bulbs as and when they fail in service, then what will be the optimal group replacement period? Means at what fixed intervals we have to make the group replacement is a question. And another question is, at what group replacement price per bulb will a policy of strictly individual replacement becomes preferable to the adopted group replacement policy? So in the first question we'll find at what fixed interval the group replacement should be done when the cost per bulb when purchased as a group is 32 pice. So what if at all it is not 32 pice, if it is some other x, if it is some rupees x, so what should be the value of x for a group for a replacement as a group, as a lot, will make this individual replacement a better solution is a question. So let us try to solve this problem. The given question shows us the cumulative probability of failure. So let Pi be the probability that a bulb that is newly installed fails during ith week of its life. Since all the given probabilities are cumulative, Pi is an individual probability that should be found as an individual probability for an ith week. So as already explained, it will be for first week, let it be P1 for first week. Ith week it is Pi, so for first week it will be P1. It is given as 0.03. Probability of failure by the end of second week will be this 0.15 is cumulative, means here in this 0.15 this 0.03 is also there. So 0.15 minus 0.03 will give us the individual probability of that week, probability of failure in that week. It is 0.12. Similarly, P3 is the probability of failure by the end of third week. It will be cumulative up to third week is 0.24 minus cumulative up to second week is 0.15. So that will give us individual failure probability of third week, which is 0.09. The same fashion we will find P4, P5, P6, P7 and P8 up to 8 weeks. So P4 will be 0.44 minus 0.24, which is nothing but 0.2. P5 will be 0.67 minus 0.44, 0.67 minus 0.44. This will be 0.23. P6 can be written as, P6 means up to 6 minus up to 5. Probability up to 6th week is 0.85 minus probability up to 5th week is 0.67. We are doing this only because the given question is having values with cumulative probability of failure. If the question has in it individual probability of failure of a week, then we are not supposed to do all these things. Alright, so in the question it is clearly mentioned that it is cumulative probability of failure what is given, and by the end of the 8th week the probability became 1, means all the 1000 or whatever, the entire lot of bulbs is failed. So that means this is cumulative. So we are finding the individual. If the question is giving us individual, you don't do all this subtraction. So this will be 0.18 and P7 is equal to 0.95 minus 0.85, which is 0.1, and P8 is equal to 1 minus 0.95, which is 0.05. So as we know, sum of probabilities will be 1. So if you add all these things, 0.03 plus 0.12 plus 0.09 plus 0.2 plus 0.23 plus 0.18 plus 0.1 plus 0.05, you will get 1. Alright. And that is what is seen here. This one is this one only. So since the sum of probabilities is equal to 1, and the sum of probabilities it can be never greater than 1. Sum of probabilities must be 1. So any probability beyond P8 will be 0. Means even if at all you try to find the P9, it will be 0. So there's a bulb which has lasted for 7 weeks. A bulb that is lasted, so means the bulb age is 7 weeks. Alright, so so even if it has survived up to this 7 weeks, it is sure to fail in this 8th week. So according to this probability by the end of 8th week is 1, means every bulb is failing at this particular limit. In this time limit, every bulb, all the 1000 bulbs are failing. So there is no single bulb that is left here. Okay. So that means any bulb that is lasted for 7 weeks will definitely fail during the 8th week. So for a given lot of 1000 bulbs, so it can be seen that how many bulbs are failing by the end of 8 weeks? All the 1000. So for a given lot of 1000 bulbs, it can be seen that at the end of 8th week, Pi of 1000 number of bulbs fail. That means 1000 into Pi, these many number of bulbs will fail. So by the end of 8 weeks, there are no bulbs that are left to fail. So that means even if you want to write P9 into 1000 or P10 into 1000, these are zeros. So the number of bulbs that will fail in from the 9th week is 0. So let me tabulate all the probability of failure for the given week. We have found this, no, P1, P2, P3. So let me just write them down here. It is 0.03, this is 0.12, then it is 0.09, P4 is 0.2, and this is 0.23, 0.18, 0.1 and 0.05. So by the end of 8 weeks, 100% of the bulbs are failing. Means what? Sum of all these probabilities, 0.03 plus 0.12 plus 0.09 plus 0.2 plus 0.23 plus 0.18 plus 0.1 plus 0.05 is equal to this one, right? This one. So 100% all the bulbs are failing. So that means by the end of first week, 3% of the bulbs are failing. 3% means it's 0.03 into whatever is a given number of total lot. Total lot is 1000. So the number of bulbs that are failing by the end of first week is 0.03 into 1000. So in 1000 bulbs, 30% are failing. So if we say that by the end of 8th week, 100% all the bulbs are failing, then how is that 100% becoming? They are not failing it all 100% in 1 week, right? They are distributed. So out of 1000, by the end of first week, this 0.03 means 3%. 3% of the bulbs are failing by the end of first week. This is nothing but our 0.03 into 1000. How many bulbs are failing in the second week? It is this 12% of the total lot. So it is 0.12 plus into whatever is the lot. Lot size is 1000. The total is 1000. So in the third week, it is 0.09 into 1000. So out of 1000, 9% of the bulbs are failing. So similarly, by the end of 4 week, in the fourth week, how many are failing? It is 20%. 20% are failing in fourth week. 23% are failing in fifth week. 18% are failing in sixth week. 10% are failing in the seventh week. And just 5% are failing in the last batch is 5%. So if we, because the sum of probabilities is all 1, if you want, you can add these up. The number of bulbs failed in the first week is this. Calculate this, write down the number x1, find this, it is x2, find this value, it is x3. You sum up x1, x2, x3, x4, x5, x6, x7, x8 and all. Sum of x1, x2, x3, x4, x5, x6, x7, x8, that will be the 1000. So all 1000 are failed by the end of 8 weeks. So let us put them up in a better way. So according to the probability distribution, number of failures is nothing but total number of bulbs during installation multiplied by probability of failure for that given week. So this product will give us the number of failures in that week. So whatever I have just explained you here is written in the form of a formula. So this is according to the probability distribution. That is how we find. So alright. So what is the formula that we have written? Total number of bulbs during installation. So every number, every x1, x2, whatever it is, this 1000 is what we are talking about here. Probability of failure for that given week is this one. So whatever you pick, it is from the same formula. I just explained the concept first and I am giving you the formula here. So while explaining the concept, I have mentioned you roughly some x1, x2, x3, right? So let us take it as some ni, some capital Ni. Let ni be the number of failures in the ith week. So means I am writing this x1 as n1, this x2 as n2, this x3 as n3 and so on. This is n4, this is n5. So let this total number of failures per week, if for first week or second week or for 8th week, let that be capital Ni, I for the week. So let us find it for the first week. N1 is nothing but, what is it? Total number of bulbs during installation is 1000 multiplied by probability of failure for that given week. What is the probability of failing in that week? It is this 0.03, which is P1 nothing but 1000 into 0.03, which is equal to 30. So that is what we have I've mentioned here. This is 0.03 into 1000. So similarly, the number of failures in the second week is 1000 into P2. 1000 into, what is P2? P2 is this one, 0.12, the individual, this one. That is nothing but 120. So 30 bulbs are failing in first week. 120 bulbs are failing in the second week. You getting me? This is what it is. 0.03 into 1000 is nothing but 30. 0.12 into 1000 is nothing but 120. So similarly 0.09 into 1000 is nothing but 90. So this 0.2 into 1000 will be 200. That is what we are writing here neatly. So N3 is equal to 1000 P3. That is 1000 into P3 is 0.09, which is 90. So N4 is equal to 1000 P4, that is 1000 into P4 is, I is 4, so P4 will be this 0.2. This is 200. Similarly N5 is 1000 P5, which is 230. N6 is 1000 P6, which is nothing but 180. N7 is 1000 P7. P7 is 0.1. This is 100. And finally N8 is 50. So if you want, you can add these all: 30 plus 120 plus 90 plus 200 plus 230 plus 180 plus 100 plus 50 will come out to be 1000. All 1000 bulbs are failed. So how are these 1000 failing? They are not failing all at once. In the first week 30 are failing. In the second week 120 are failing from the same 1000. In the third week from the same 1000, 90 are failing. Alright, so here the total number of bulbs in the first week is 1000. 30 got failed. So in the second week, how many bulbs are left? 970, out of which 120 are failing. So in the third week, how many are failing? 90, out of what? 970 minus 120 means 850. From 850, 90 are failing. So here in the similar fashion, finally all the bulbs are only 50 will be left in 8th week, all the 50 will be failing in by the end of 8th week. So this N1 and 2 values of N1 and 2 N3 N4 N5 N6 N7 and N8 are most important. So I am labeling this as some table 1. The table 1 will have the values of Ni. So in all this, no replacement is considered. Alright, these values are just giving the total number of failures per week. Alright, and after week 8, that is from 9th week, there is no more bulb, that is no bulb is left. So that cannot fail. So that means if we want to find sigma Ni, we can write it as, I is from 1 to 8. We can write this as 1000 P1 plus 1000 P2 plus and so on 1000 P8. We can take this 1000 common. What do we get? Sigma I equal to 1 to 8 Pi. What is sigma Pi? It is 1, which is already given in the question. Cumulative, this is 1. Or even if you find all the P1, P2, P3 will be 1. So this is nothing but 1000 into 1, which is 1000. So therefore, in the above order, what order? 30, 120, 90, 200, 230, 180, 150. In this order, the bulbs will fail every week, and by the end of 8th week, the total lot is lost. But for the production to be continued, the bulbs are replaced individually as and when they fail. Alright, even if the question doesn't say it, that is what an assumption. In the introduction only we have discussed that. So, but otherwise here also it is mentioned that individual bulbs are replaced as and when they fail in service. Okay. So every week the number of failures out of 1000 is already calculated as can be seen from this table 1. Now suppose at the end of week 1, how many are failing? Out of that 1000 lot, the lot is 1000. This is the first initially installed. So of which by the end of first week 30 are failed. Alright, so as and when they are failing, we are replacing as an individual bulb. So that means now at the end of week 2, the number of failures, how do we find the number of failures? It is no more our 1000 into Pi. Alright, see here, out of this 1000, first 30 are failed. By the end of week 1, first week, 30 out of the initial 1000 bulbs failed. So when these 30 which are failed are not replaced immediately after they failed, the total number of bulbs will come down to 970. 1000 minus is 30. But as we are replacing every bulb as and when it fails, now what is the total number of bulbs in the second week? We are replacing all 30. So this will be 970 plus 30, which is again 1000. But now, how do we find the number of failures? This 9 out of this 970, how many are failing? 120. How? From this. The probability of failure when the age of bulb is between after 1 week and by the end of 2 weeks is 12%. Alright, so when this 970 bulbs are of age more than 1 week, so during the second week, when its age is second week, the probability of failure is 12%. So 12% of the 1000 is this 120. The age of this, the age of second week is only for the 1000 bulbs. This 970. But there are newly added 30 bulbs in the individual replacement policy. Here we are adding this now newly added 30. The age of this 30 is 1 week only. So the probability of failure for this 30 must be P1. The probability of failure for this 970 is P2. Therefore, by the end of week 2, the number of failures of the replaced 30 means the new 30 is P1 because their age is 1 week only, and the number of failures of the old 1000 is P2. So the total number of failures will be number of failures of this 30 by P1 plus the total number of failures of the old 1000 of P2 will be calculated. This plus this, nothing but 30 P1 plus 1000 P2. So therefore, by the end of second week, the total number of failures will be that 1000 P2 plus 30 P1. Now you may ask me why 1000 P2, because now it is 970 only. Why not 970 into P2? Some people might get this question or doubt. So let me answer this now. That by the end of second week, if at all there is no replacement, means there is no new 30 at all. This 30 is not there. We are not replacing, only 970 are left. How many are failing from 1000? It is this 120, right? So this 120 is for all the 1000. Means 120 are failing from 1000 bulbs, of which 30 are already failed. That is the reason we are getting this 970. But otherwise, this 120 is calculated as a failure out of 1000 only. This is 1000 into 0.12. The total number of failure in when the age is 2 weeks or more than 1 week. 1 week to 2 week is 120. So I will write this as how many bulbs are failing in the second week? 120 are failing, because the probability for that is P2. P2 is 0.12. So it is 1000 into P2, which is our N2. So this is 120. So out of 1000, 120 are failing. Now we are when the 30 in the first week which failed are replaced. So now how many are failing from this 30? The probability of failure, because its age is 1 week, it will be P1. So it is 120 plus 30 into what is P1? 0.03. What is this 120? This 120 is nothing but 1000 into P2. That is what is written here. 1000 P2 plus 30 P1. So it is not 970 P2. It is not 970 P2. Out of 1000, 120 are failing. We have found all the failures based on the lot size, the total. Out of 1000, 30 are failing here. Out of 1000, 120 are failing here. This 120 is not taken from 1000 minus 30. No. I told you that if at all replacement is not happening, then in this week 970 are left. Only 970 are left. But otherwise, the failure is from this 1000 lot. How many bulbs have we installed first? 1000. So out of 1000, 30 are replaced. 30 are failed in first week. 120 are failed in the second week. 90 fails in third week. Only then sum of N1, N2, N3 and so on up to N2 will become 1000. So if you have a confusion with this formula and all, what you can do is, anyway we have how many bulbs are failing from the first lot. That is table 1. You note it down. By the end of second week, how many should fail from the first lot? It is 120. How many will fail now? How many are new? 30 are new. Because this 30 failed in first week. We already have it in our table 1 again. Now, what is the probability of these failure? All 30 will not fail, right? It is according to P1. So, it is 120 plus 30 P1. Similarly, by the end of third week, how many will fail from the actual lot? 90 will fail. Alright. But this 120 number of bulbs are failed in second week. So 120 are replaced. Now what is its age? 1 week. By the end of second week, by the end of third week, in the third week 90 are failing. By the end of second week 120 failed. No, those are replaced. Now its age is 1 week, so failure will be according to P1 plus whatever is left in this 30. All 30 did not fail, right? So that 30 age is now P2. Now this will be the total number of failures by the end of third week. So therefore, when individually, whenever a bulb is failing as we are replacing, the total number of failures is changing. Alright, because all the time we are always having 1,000 lot. So here, let us write everything neatly now. By the end of first week, 30 out of the initial 1,000 bulbs are failed. So the total number of failures by the end of first week is 30 only. So by the end of second week, the total number of failures, considering that the failed 30 from first week got replaced, can be given as our 120. 120 is nothing but 1000 P2 plus the 30 P1. So considering the individual replacement is happening, let us give these names. Let this be N1 dash, N1, N2, N3 and so on are different. When replacement is not happening, this is what the total number of failures per week is, in every week is, right? Here replacement is happening, so let us give a new name, N1 dash. So let this be N2 dash. This is 1000 P2 plus 30 P1. 1000 P2 is nothing but our 120, which is this, and 30 into P1. P1 is 0.03. So this is 120 plus 0.9. That becomes 120.9. And we are talking about bulbs. So the number of bulbs is an integer. It should be integer. So let us round it up to a higher number. Let it be 121. So by the end of second week, the number of failures is 121. Now let us find the total number of failures by the end of third week. Let it be N3 dash. So how many are failing in the third week? Out of that 1090 is in any way failing. It is that 90 plus what is it? The age of this 121 is 1 week. So it is 121 into P1 plus this 30. The age of this 30 is now 2 weeks. So the number of failures from that 30 will be 30 into P2. So we can write this as, what is this 90? Actually it is 1000 into P3, right? So we can write our N3 dash as 1000 P3 plus 30 P2 plus 121 P1. So this is 90 plus 30 into 0.12 plus 121 into 0.03. So this is equal to 97.23. Because it should be an integer, I am rounding it up to 98. So N3 dash is 98. So when bulbs are not replaced as and when they are failing, the total number of failures that time was just 90. This 90 is because only 850 were left, out of which 90 were failed, but now we made them 1000. Every week whenever something is failing, we are replacing it. So that is because of the law, we are replacing individually, and the ages of the bulbs are changing. We are having now a different value. It is no more 90, it is 98. So in a similar fashion, we have to find the total number of failures by the end of 4th week, 5th week, 6th week, 7th week and 8th week as N4 dash, N5 dash, N6 dash, N7 dash and N8 dash. N4 dash is equal to it. If we carefully observe, this is all like the same formula. What is this 30? It is 1000 P1. This is 1000 P2 plus 30 P1. This is 1000 P3 plus 30 P2 plus 121 P1. So I can write it N4 dash as 1000 P4 plus now 30 P3 plus 121 P2 plus 98 P1. because now the 30 bulbs are having age 3, 121 bulbs have age 2, 98 bulbs have age 1 week. So this can be written as this 1000 P4 is nothing but N4, which is 200. 30 into P3, which is 0.09 plus 121 into 0.12 plus 98 into 0.03. This P1, P2, P3 and so on, these values are taken from already calculated here. So this comes out to be some 220.16. So I'm rounding it up to 221. So this is N4 dash. So similarly N5 dash can be written as 1000 P5, because this 1000 bulbs are having age 5 plus this 30 bulbs have age 4th week, 121 bulbs have age 3 weeks, 98 bulbs have age 2 weeks, plus these are the newly replaced in the 4th, right? So it is 221 P1. They are replaced in 4th week, so in the 5th week their age is 1, so the number of failures is P1 into that 221. So this is 1000 P5 is nothing but N5 is nothing but 230 plus 30 into 0.2 plus 121 into 0.09 plus 98 into 0.12 plus 221 into 0.03. This is equal to 265.28. So 266. So N6 dash is 1000 P6 plus 30 P5 plus 121 P4 plus 98 P3 plus 221 P2 plus the newly installed is this 266 P1. Now that we have understood how to find the total number of failures by the end of any week when every bulb that fails is replaced then and there itself, let me write this in general terms. We already learned how these numbers are written. So I will write it in a general term so that we can frame it as a formula. And if you can memorize it, then you can solve any problem using that. Now let this initial installed number of bulbs be, say, some N naught. So let this 1000 be N naught. Alright, so this is N naught P6. Okay, I am writing these in terms of a formula. This 30 is nothing but our N1 dash, it came from here. So that 30 is N1 dash P5 plus what is this 121? 121 is N2 dash. This 121 is this N2 dash. So it is N2 dash P4 plus 98 is N3 dash. So it is N3 dash P3 plus this 221 is N4 dash P2 plus this 266 is our N5 dash, this one N5 dash P1. So N6 dash can be written as N0 P6, the 6th week. The 6th week age is for the initial installed number of bulbs, this one, plus in the first week 30 have failed, right? So its age in this particular period is 5 weeks. So it is N1 dash P5. And in the second week, whatever is replaced is this N2 dash. Its age by now is 4 weeks. So in the 6th week, the age of this N2 dash is 4 weeks. So and so on. So with this in this pattern, we can find any Ni dash. Say for example, we can write N5 dash using the same pattern as N naught P5, this is N naught, this is P5, plus this is nothing but N1 dash P4 plus N2 dash P3 plus N3 dash P2 plus N4 dash P1. So n's will start from the 0th week, means initial installation. N naught, N1, N2, N3, N4. So to find N5 dash, will start from N naught to N4 dash. N naught, N1 dash, N2 dash, N3 dash, N4 dash. So we using up N dashes, N naught and N dashes up to 4 weeks, we will be finding the 5th week. And the probability, the age will be P5, P4, P3, P2 and P1. For the latest ones it is 1. So for the old aged ones it is the higher number, this one. So even if you do not have much time to understand all the numbers and put it as equations, till now we have done like that, right? So if you can remember this pattern of remembering the formula for Ni dash for any ith week, we can simply get the answer. So similarly I can write N4 dash. N4 dash can be written as N naught P4. This 4 is this, because the initial installed ones are of age 4, plus it is N1 dash P3 plus N2 dash P2 plus N3 dash P1. So if you substitute, if you just look at this, N naught is nothing but 1000, N1 dash is nothing but 30, N2 dash is 121, N3 dash is 98. So we have developed this pattern or formula from the concept that we have already learned. So here N3 dash also can be written in a similar fashion. N naught P3 plus N1 dash P2 plus N2 dash P1. We can write N2 dash also in the same fashion. It is N naught P2 plus N1 dash P1. And N1 dash is nothing but N naught P1. So now that we know how to write, how to find any number of failures when individual replacement is considered, we can find any N dash. So let us find the value of N6 dash. It is 1000 into P6. 1000 into P6 is nothing but our N6, which is 180. 180 plus 30 into P5 is 0.23 plus 121 into 0.2 plus 98 into 0.09 plus 221 into 0.12 plus 266 into 0.03. So this is equal to 254.42. So I am rounding it up to 255. Always take the higher integer. So let us find N7 dash this time using the formula. So we can write it as N naught P7 plus N1 dash P6 plus N2 dash P5 plus N3 dash P4 plus N4 dash P3 plus N5 dash P2 plus N6 dash P1. This is equal to N naught P7 is N7, which is 100 plus 30 into 0.18 plus 121 into 0.23 plus 98 into 0.2 plus 221 into 0.09 plus 266 into 0.12 plus 255 into 0.03. So this is equal to 212.29, which is approximated to 213. And similarly we will find N8 dash. So I'll substitute all the values. This is N8, which is 50 plus, which is 202.45. I'm rounding it off to 203. So let us name all these N1 dash, N2 dash, N3 dash up to N8 dash as table 2. In table 1 we got N1 to N8. In table 2 we get N1 dash to N8 dash. Alright. So in the question it is given that if a decision is made to replace all the bulbs at a time, means group replacement as a group, at fixed intervals, then at what fixed interval should we do it? Alright. The fixed intervals that we can consider are only weeks, because the probability distribution that is calculated and whatever is given is in terms of weeks. So let us find the cost of individual replacements of bulbs. The cost of individual replacement of bulbs can be calculated as cost of the individual bulb multiplied by the average number of failures per week. So the cost of replacing an individually failed bulb is 1.3 rupees. It's given. This is 1.30 rupees multiplied by the average number of failures per week. So we shall now find the average number of failures per week. We can find the average number of failures per week as the ratio of total number of bulbs to the expected life of a bulb. So then it will be total number of bulbs is 1000 divided by expected life of the bulb. But the expected life of bulb can be calculated as sigma I pi. Here I is in terms of, it gives in terms of weeks. So how many weeks? 1 to 8, because the life is counted in weeks. So we can find expected life of a bulb as 1 P1 plus 2 into P2 plus 3 P3 plus 4 P4 plus 5 P5 plus 6 P6 plus 7 P7 plus 8 P8. So P1, P2, P3 they are already calculated from the cumulative probability that is given in the question. This is given, right? So we have found P1 to P8. Let us use these. Therefore it is 1 into P1, which is 0.03, plus 2 into P2, which is 0.12, plus 3 into P3, which is 0.09, plus 4 into P4 is 0.2, plus 5 into P5 is 0.23, plus 6 into P6 is 0.18, plus 7 into P7 is 0.1, plus 8 into P8 is 0.05. So this comes out to be 4.67 weeks. So since expected life of bulb is 4.67 weeks, we can find the average number of failures per week as 1000 by 4.67, which is 214.13. So we'll round it up to 215. These are the number of failures, right? Average number of failures per week is 215 bulbs. So as we have calculated the average number of failures per week as 215 bulbs, now let us find the cost of individual replacement of bulbs. We needed this to find this, right? So therefore the cost of individual replacement of bulbs is nothing but the cost of individual bulb, which is given as 1.3 rupees multiplied by average number of failures per week. Average number of failures per week is calculated as 215 bulbs. Let us apply them here. This is the cost of individual replacements of bulb is equal to 1.3 rupees multiplied by average number of failures per week, which is 215 bulbs. 215. This is equal to rupees 279.5. So this is the cost of individual replacement of the bulbs that have failed. Now let us check with the group replacement policy. What is given in the question is, if the bulbs are replaced individually, then the cost per bulb is 1.3 rupees. else means otherwise, if the bulbs are replaced as a lot in a group, means all simultaneously all 1000 bulbs, then the cost per bulb is rupees 0.32 or 32 pice. So let us now calculate the cost of the group replacement when adopted in the ith week. The initial cost for all the bulbs is, we have bought all the 1000 bulbs and we have installed, right? So that will be N naught. And what is the price when we are buying in a lot? Per bulb it is 0.32 rupees only. So it is 0.32 into the lot size. What is the lot size? It is 1000. 1000 into 0.32. Each bulb is 32 pice. So this is 320 rupees. So initially when we have installed all the bulbs newly, then we had paid 320 rupees. Let us take down it as table 3. So let us note down the group, the week number on the first column, group replacement after week I. So after first week, if we are replacing the entire lot, we should find the total cost of that group replacement. So initially when we have just begun the 0th week, what is the cost? Initial cost is this 320. So we have already kept 320 rupees in it. Now after if at all we are replacing all 1000 bulbs at the end of week 1, at the end of week 1, how many bulbs are failing? Let us go to table 2. Why are we going to table 2? Why not to table 1? Table 1 means here it is, we are not considering that in table 1 we are not considering that the failed bulbs are replaced as and when they are failed. But in table 2 we are considering that whenever a bulb is failing, it is immediately replaced. Alright. So by the end of week 1, how many bulbs are failing? 30. So this 30 number of bulbs are also replaced. So that is also an added cost. So the cost of those individual replacements that have failed by the end of first week is that 30, which is nothing but our N1 dash. This is the number of bulbs that are failed by the end of week 1. But what is its cost? Its cost is 1.3 rupees. If we are buying or we are replacing all 1000, only then it is 0.32 rupee per bulb, but otherwise it is 1.3. So the cost incurred for this N1 dash is 1.3. N1 dash into 1.3. So this will be the total cost. What will be the total cost? It is 320 plus 30 into 1.3, which is 359. So average cost per week is rupees 359. Now if at all we are going for a group replacement by the end of second week, so the initial cost is 320, that is already there. That 320 plus whatever the N1 dash is. Now that N1 dash multiplied by 1.3 plus by the end of second week, we are already also having the N2 dash number of bulbs that have failed. So that N2 dash is also having the same cost, 1.3. Or I can write it as 320, which is the initial cost, plus 1.3 into N1 dash plus N2 dash. So now N2 dash from table 2 is our 121. This one. Written from here. So for my comfort, I have taken down the table 2 here. Now I will use values from this table 2. This is 320 plus 1.3 into N1 dash is 30 plus N2 dash is 121. This one. This is equal to 320 plus 1.3 into 151, which is 516.5. 3. So the average cost per week will be this 516.3 by 2. See what we mean by all this is, if at all we are going to replace all the bulbs as a lot. So every time you are replacing all 1000 bulbs by the end of first week, say. So that 320 cost for 1000 bulbs is there, and during the first week, by the end of the first week, 30 bulbs are anyway lost, they are failed. So the cost of this is 1.3. So if you are doing this group replacement of all 1000 bulbs plus the bulbs failed during that first week, every week you have to spend this 359 rupees. So taking the decision of group replacement after every first week is this costly, 359 rupees. Now if the decision is to replace all the bulbs, whether every bulb is filled or not, because all the bulbs will fail only at the end of 8th week, right? But otherwise every second week we are going, if we have decided to replace all the bulbs, then what is the cost? The cost is that for all the 1000 bulbs it is 320 rupees, plus when we are deciding to replace after first week, then it is initial cost which is for the 1000 bulbs, plus there are bulbs that are failing by the end of first week. The first week is a target, the 30 are failing, and by the end of second week 121 bulbs are failing. Alright, so this 1000 bulbs cost is 320. This 30 bulbs and 121 bulbs is 1.3 rupees per bulb. That is the cost of that. So total cost by the end of second week is what? 516.3 rupees. Now what is the average per week? My decision is I will go for a group replacement of all the bulbs for after every 2 weeks. So per week what is the cost? It will be 516.3 by 2, which is nothing but 258.15 rupees. So if you observe, if at all our decision is to replace all bulbs every week, then the cost is through 359. If we have decided to replace all the bulbs, whether everything is failed or not, then the cost per week is 258 rupees, 258.15 rupees. So cost is coming down. So let us see what will happen when our decision is to replace all the 1000 bulbs by the end of or after third week. So the cost of decision of replacing all the bulbs after every 3 weeks will be 320 plus, you might have already observed the pattern, it is 1.3 into the first week N1 dash are failed, in second week N2 dash number of bulbs have failed, and in the third week N3 dash number of bulbs have failed. So that means this is 320 plus 1.3 into N1 dash is 30, N2 dash is 121 plus N3 dash from table 2 is this 98. This comes out to be just our this 320 plus 1.3 into 30 plus 1.3 into 121, which is 516 point plus all that is new here is the N3 dash. So its cost is 1.3 into 98. So this comes out to be 643.7. So the cost for when we have decided to replace all the bulbs after every 3 weeks is, the total cost is 643.7 rupees. Per week how much are we spending? It is 643.7 by 3, which will be equal to 214.5666. So I will take it as 57 rupees. 214.57 rupees. So the decision of replacing all the bulbs after the end of third week is less costly compared to 2. So first week is costlier, second week is reduced from first week, and third week is much lesser. So let us see what will happen if we decide to replace all the bulbs after every 4 weeks. So that will be 320 plus 1.3 into N1 dash plus N2 dash plus N3 dash plus N4 dash. So this is nothing but our 643.7 plus 1.3 into N4 dash, right? Or this is nothing but I'll go with the formula. I'm just writing down as it is. N4 dash is 221. This one. This is equal to 931 rupees. So total cost for 4 weeks is 931. So per week it will be 931 by 4, which will be equal to 232.75 rupees. So if we try to compare, the cost per week when the group replacement has to be done after every 3 weeks is lesser than that when it is done after every 4 weeks. So if we check with the pattern as how the costs are changing, from first week it started decreasing until third week, and then it started increasing. So 359 is greater than 258, which is again greater than 214.57, which is less than the next one, 232.75. So the cost decreased and then increased. So this decrease happened when time is 3 weeks. So as the cost is increasing from 4th week, every time it will be increasing. So if you want, you can try it out and see. But otherwise here I am closing. My optimal answer is that it has decreased at 3 and then increased. So what is least, what cost is least is optimum solution for me. So therefore from the table it is clear that it is optimal to have a group replacement after every 3rd week. So here in the question it is mentioned that if a decision is made to replace all the bulbs at a time at fixed intervals and replace individual bulbs as and when they fail in service, what will be the optimum group replacement period? We have found that fixed interval is 3 weeks. After every 3 weeks we have to go for a group replacement. And how did we find that? We have considered values from table 2, because here it is mentioned that find the group replacement period when individual bulbs are are replaced as and when they have failed. So that is considered only in table 2. So the answer for this question is the group replacement period is 3 weeks and the cost is 214.57 rupees, which is even much less than the cost when individual replacement is considered. When individual replacement is considered, we have found the cost of individual replacement of all the bulbs, right? And we found it as 279.5 rupees, which is much higher than our 214 rupees. Now the second question is, at what group replacement price per bulb will a policy of individual replacement become preferable? Means till now, until here, if we cross check between the individual replacement cost and group replacement cost, because individual group replacement cost, this 279.5 rupees is much greater than, or even if it is 1 rupee greater, it is greater than our group replacement cost, which is nothing but 214.57. So this is greater than 214.57 rupees. So therefore what is preferable in both the cases, whether individual or group replacement? Because this is less, group replacement is preferable. Now the second question is, at what group replacement price per bulb individual replacement becomes less costly, or for what group replacement price per bulb? Means group replacement price per bulb is 0.32 rupees. What should be the price of this, which is not 0.32, it should be something else, not 0.32. So let that be some x. Alright, so if x is the price per bulb when bought in lot, so for what value of x our individual group replacement policy cost is lesser than this 279.5 should be less than the group replacement price. So what should that x be instead of 0.32 is a question. So let us find that x to solve that second question. To find the group replacement price per bulb at which a policy of strictly individual replacement becomes preferable. So let X be the group replacement price per bulb. So when will group individual replacement be preferable? As we have seen, it should be the group replacement price must be higher than the cost of individual bulb individual replacement. Individual replacement cost is what? This one. That means the cost of individual replacement of bulbs must be less than this optimum answer which we got now, which is 214.57. But how did we write this how did we get this 214.57? This one, this 214.57 is nothing but 643.7 by 3, this one, which is obtained from here. Alright, from this. So let me write this 214.57. I cannot write it as 214.57 anymore, because this 214.57 is obtained by considering the value of group replacement price per bulbs as 0.32 rupees. That 320 is there here. Because of this 320 we got this value. We have to find that what value of we have to find what should be that X instead of 0.32. From 0.32 only we got this 320, right? So therefore I have to write it in terms of general formula. So therefore the cost of individual replacement of bulb should be, what is that? How did we get this 214.57? It is the average of these terms, right? Let us see this. What is that 320? How did we get that 320? It is 1000 into group replacement price. Here group replacement price per bulb is X. So that is 1000 into X, or otherwise I will write it as a formula first. N naught is that 1000, right? N naught into X plus individual bulb cost is not changing. He did not mention that. So I am using the same thing. So when is this replacement happening? Actually, when the group replacement price is only 32 pies, it is happening at the end of third week, right? So for that the formula will be, this is nothing but N naught into that X plus 1.3 into N1 dash plus N2 dash plus N3 dash. You can write it as N1 dash plus N2 dash plus N3 dash divided by 3, because the actual answer is, it is that 214.57. That is happening by the end of third week only. So this must be divided. The average will be by 3. So what is the cost of individual replacement of bulbs? It is 279.5. So this should be less than our N naught, our this RHS, which is N naught means 1000 into X plus 1.3 into N1 dash, N2 dash, N3 dash can be found from table 2. 30, 121, 98. So that is 30, 121, 98. This divided by 3. So in this equation there is only one variable which we can easily solve and find. So I am cross multiplying this 3, I am taking that here. We can write it as 279.5 into 3 is less than 1000x plus 1.3 into 30 plus 121 plus 98, or I'll shift all this here. So that will become, this is all positive number, it goes here, it becomes negative, right? So it will be minus 1.3 into 30 plus 121 plus 98. This should be less than 1000x, or otherwise 279.5 into 3 minus 1.3 into 30 plus 121 plus 98 whole divided by 1000 should be less than x. So on solving our LHS, we get it as 514.8 by 1000 should be less than x, or otherwise x should be greater than 0.5148 rupees. So that means if the group replacement price per bulb is greater than 0.5148 rupees, then a policy of strictly individual replacement becomes preferable. So this is the answer to the second question. So try to solve this question. The following are the probabilities of failure for resistors of an electrical system with 100 resistors at the time of installation. If a resistor fails in service, it costs rupees 3 per resistor to replace. But if all the resistors are replaced in the same operation, it can be done at 0.7 rupee a resistor, means 70 pice only. So the questions are: A, you have to find the best interval between the group replacements. B, also establish if the policy as determined by you is superior to the policy of replacing resistors as and when they fail, and there being nothing like group replacement. And C, at what group replacement price per resistor would a policy of strictly individual replacement becomes preferable to the adopted policy. So here also the age or the timeline is in terms of weeks. Probability of failure for at the end of every week is given here. So try to solve this question and put down the answer in the comments below.
Thanks for watching. If this video was of help to you, please like it and share it with your friends. And don't forget to subscribe to our channel.